was larger. As I said, the effect was driven by changes in movement kinetics, for instance the timing of the downswing as well as the extension and flexion movement of the hips. And it seems as if gymnasts organized their coordination with regard to a gaze behavior that best serves the current circumstances of the situation from trial to trial. And this is something that, from my point of view, should be emphasized in gymnastics training. Here you see a final example of the relationship that I talked about between gaze behavior and motor behavior. So gymnasts were asked to perform backward somersaults after a snap down movement on the miniature trampoline. During takeoff, their gaze was directed by means of a laser pointer. It was either directed straight ahead, that's the baseline condition, or gaze was lowered about 30 centimeters, or gaze was raised about 30 centimeters. The results were quite obvious, even if you are not able to see the landing position, then manipulating your gaze or directing your gaze leads to significant changes in your motor behavior, and these changes were here related to landing position, but also to kinematic parameters such as the angle between the legs and the trunk. So you can see the results of the leg trunk angle here, when the light spot was lowered, when the light spot was raised, and during the baseline condition. You see this step-like pattern of results, so a clear relationship between gaze direction again and some kinematic parameters. Even if these changes are not that large, so 175 degrees about, and about 180 degrees, so only 5 degrees difference. However, these relationships are significant and also systematic when directing your gaze and performing these complex skills. Using visual strategies may also impact motor skill acquisition. It's not that it directly impacts motor behavior, but also motor skill acquisition. And here you see a study that was published together with Hardy Fink. We had students of sports science, no expert gymnasts, sorry for that, but students of sports science learn the handspring in gymnastics, as you can see in this picture. So quite normal setup when learning the handspring in the sports science program at the University of Hildesheim. And yeah, gymnasts were asked to learn this handspring. We also had a control group that was asked to learn the handspring with traditional methodology or traditional progressions without a specific emphasis on gaze behavior. And 2 experimental groups learned the handspring with a special emphasis on gaze behavior. In particular, their gaze was directed by means of such visual markers put on this gymnastics box here, or a landing area there, or on the distant wall. This was for one experimental group, and another experimental group has received instructions on where to direct their gaze during specific movement phases. And here you can see the results. We did a performance rating of some expert coaches. You see the data for post-intervention phase, so after they learned the handspring, 4 weeks training time, and a retention situation, that's another 2 weeks after the training was over. All 3 groups reached quite a respectable level in handspring performance. However, only the groups, and this is the cues group and the instruction group, so this group here and this group here, but not the control group, only the cues and instruction group, not the control group. They had exceptional performance in a retention test. So they learned the handspring, but they did not forget what they learned. And in addition to these changes in movement quality, there were also changes in movement kinematics between the control group and the experimental group. So the instrumental group both showed a higher runner velocity, higher amount of angular momentum, better repulsion phase, better second flight phase, and so on. So we can conclude that perceptual instructions in forms of verbal instructions or cues or markers facilitate skill acquisition in gymnastics if they are specific to the functional demands placed upon the visual system in the performance context. So it makes no sense to direct your gaze to areas that are not functional for task execution. This may hamper performance, but of course you have to find the functional areas of interest that drive your motor behavior and optimize your motor behavior. As I said earlier, we now come to the role of environmental information in complex skill performance, because it adds to the role of visual strategies in complex skills, and it's quite an interesting idea to think about how environmental cues drive your motor behavior, because you always have different situations in gymnastics. You come to a totally different gym, you have to adapt to your environment, different information, different environmental information. However, you try to use them in skill performance, and so I hope that this is quite an interesting topic for coaches. So in order to characterize some of the relevant ideas on the role of environmental information, you see an example mentioned earlier on running towards the vaulting table, elaborated in more detail here. So the gymnast, as you can see him standing over here, facing the vaulting table. When he runs towards the vaulting table, at the beginning he may potentially fixate the vaulting table to get an idea where to run. In later phases he may also fixate on the springboard, as you can see here, and these fixations may be functional in the regulation of his steps. Of course, you have to adjust your steps on the running track to precisely hit the springboard, to precisely interact with the vaulting table, to precisely stick the landing. There could also be other cues that are not functional to skill performance, such as the girl standing over here. And if you use such unfunctional cues, then this may also, of course, hamper your performance. So the question, however, is, first, which are the relevant informational sources in complex skill performance? And second, how do these sources regulate motor behavior in gymnastics? So even if this is quite a nice girl, this is an unfunctional cue for handspring performance. From the idea of time to contact, one may assume that, of course, the springboard is a relevant information cue, because you have to have the ability to precisely hit the springboard at a very high velocity. You can see it in the short video sequence on the top of the slide. The gymnast runs towards the springboard, very high velocity, places his feet on the springboard, takes off for handspring 11. And in order to assess the role of the springboard position in the regulation of handspring performance, we developed a quite simple paradigm. So what we did, we manipulated springboard position without telling the gymnast. So we had gymnasts perform handsprings, and we manipulated the springboard position without telling them what we did. The manipulation of the springboard usually was about 5 to 10 centimeters, either closer towards the vaulting table or farther away from the vaulting table. And this is a distance that you won't perceive when you stand at the starting point 20 or 25 meters away from the vaulting table. You won't perceive a manipulation that is about 5 or 10 centimeters. Then we assessed gymnasts' run-ups and their foot placement on the springboard, together with the subsequent handspring. What you can see here are the results of one experiment, and we have replicated this experiment with about 60 or even 80 gymnasts. I don't exactly know, but this pattern of results is quite prototypical. All gymnasts show this pattern of results. It's such a stable result. I've never found something like this before. When we manipulated the position of the springboard, here you can see on the left-hand side, this is the baseline distance, so the individual springboard distance of this gymnast. Here we extended the distance between springboard and vaulting table, and here we shortened the distance between springboard and vaulting table, about 10 centimeters and also about 10 centimeters. If you then measure the position where the feet get in contact with the springboard, then you see that this result is really, really stable. So about 38 centimeters from the front edge of the springboard, this is where gymnasts place their feet in the minus 10 centimeters condition, but also in the plus 10 centimeters condition. So irrespective of this manipulation, gymnasts accommodate or adapt their run-up in order to precisely hit the springboard. So it makes no difference if the springboard was placed here, here. They always put their feet on approximately the same spot on the springboard. So really stable result. The means differentiated, as you can see, in the third decimal plane, so 0.825, 0.829, and the standard error was only about 2 centimeters. Quite interesting. Also, none of the gymnasts in these studies reported having perceived the manipulation. So they were thinking all the time that they were having this condition in all handsprings. However, in order to place your feet exactly on a specific spot, when running towards the vaulting table, you have to adapt your run-up or some particular aspects during the run-up. And we also assessed the strategy of the run-up from the starting point towards the contact with the springboard. And here you see the differences in foot placement during the run-up in the experimental conditions compared to the baseline condition. So baseline condition always reflects 0. Differences from 0 correspond with the experimental manipulation. And on the axis here you see the steps from the starting point, the first step, towards the touchdown on the springboard. What gymnasts did was the following. Experts that we had here regulated the last 4 steps. So you can see here the regulation or the difference in regulation between the condition where the springboard was placed 10 centimeters farther away from the vaulting table and 10 centimeters closer towards the vaulting table as compared to the baseline condition. And but you can see quite stable that they accommodate or adapt this manipulation towards the touchdown. So at touchdown they exactly adapted to this experimental manipulation, and they adapt to this experimental manipulation during the last 4 steps. So steps -3, -2, -1 towards the touchdown. Some sort of sprint run-up, some sort of regulation in order to exactly place your feet on the springboard, irrespective of where the springboard was placed towards the vaulting table. This pattern of results slightly differed between experts and beginners. We also had beginning gymnasts doing this experiment. You can see slightly larger variance in beginners. However, in general, the pattern of results is quite similar in terms of statistics. Beginners regulate 1 step later, so this difference was not statistically significant, neither so was this difference, but they also adapt to the springboard manipulation in order to place their feet exactly on the springboard. So experts as well as beginners regulate the approach run or the run-up on the basis of perceived springboard position. This, however, does not necessarily imply that gymnasts perceive the position of the springboard consciously. It can just be a subconscious information or unconscious information that leads to this regulation. Nevertheless, so springboard position, quite an important information. Similar pattern of results can be found concerning the position of the vaulting table, even the height of the vaulting table and the difference between the springboard and the vaulting table as compared to the landing position. All these information regulate different parameters in the vaulting performance of gymnasts. So sometimes it's about regulation the run-up, sometimes it's about regulation your takeoff movement, sometimes it's about regulation during the flight phase. And of course the question for gymnastics would be how all these informations, or how this field of information regulates your motor behavior. This is one of the most difficult questions. Here is some indication on the springboard position, but if you think about the manifold of information in the environment, hopefully it becomes clear that this is not such a simple argumentation as I made here, but it's quite the most complex thing in gymnastics to think about. These regulations that I talked about were quite subliminal, so neither a judge nor a coach, I'm not sure about you, but these judges or coaches that we had in our experiments didn't observe them. You see an example here. So all three conditions and handspring performance differentiates. In the last part of the skill, I'm not sure whether you can say which condition corresponded with which video sequence here. So what is the baseline, what is the condition where the springboard was put farther away, where it was put closer to the vaulting table. I have no idea, so very hard to observe. Final point that came to our mind was the question if this is task dependent. I started my talk with task dependency of gaze control or visual perception and complex skills, and here we explicitly assessed it. So the question if there is a task dependent regulation in gymnastics. If you think about all the manifold of skills in gymnastics, it would be quite probable that this is task dependent. However, you have to experimentally confirm it. And in this study, we asked gymnasts to perform two tasks that are similar in task demands, but very different in task dynamics. So you perform a mount to the balance beam and also to the uneven bars, so different task demands. Similar task demands, but different task dynamics. So a tucked leap to landing on the balance beam, and a straight leap to hang on the uneven bars. When performing the tucked leap on balance beam, usually gymnasts use more steps and exhibit a slightly higher run-up velocity as compared to the straight leap on the uneven bars. However, in both tasks, gymnasts have, of course, precisely hit the springboard. And to assess the interaction between task dependency here and movement regulation, we used the same approach as mentioned earlier. So we again manipulated springboard position without telling the gymnasts. And you may see a prototypical result already in the movie. Try to see if there's a difference in foot placement between the experimental conditions. If I show you the baseline condition here and here, maybe you see an effect on springboard position if you compare these two movements and these two movements. Maybe you see an effect on task if you compare these two movements and these two movements. This is quite a prototypical result that emerged. So task dependency in its clearest form, I guess. I have some data on that on the following slides. So as I said, there was a task-dependent effect of movement regulation in gymnastics in these two skills. And here you see the results of foot placement on the springboard when performing the two tasks. the baseline conditions here are shown in gray, and a condition where the springboard was placed 10 centimeters farther away from either the balance beam or the uneven bars. And foot placement on the springboard was quite constant between experimental conditions. So the same effect that we found for faulting also occurred here when performing this leap to the balance beam or this leap to the uneven bars. However, there was a clear task-dependent effect, so gymnasts clearly placed their feet closer to the back edge of the vault of the springboard when performing the straight leap to hang on the uneven bars, as compared to when performing the tucked leap on the balance beam. You can see the feet positioning on springboard from the front edge, so about 80 centimeters for the balance beam, about 95 for the uneven bars. So foot placement clearly differentiated between experimental tasks, but not between experimental conditions. The same was true for the hurdle movement, so the last step and flight phase towards the springboard. And the distance of the hurdle again clearly varied as a function of task dynamics, but not as a function of the position of the springboard. You can see the results here. So the length of the hurdle for the tucked leap on balance beam and the straight leap on uneven bars, and was a bit longer for the balance beam, shorter for the uneven bars, but I did not differentiate between experimental conditions. So again, a clearly task-dependent effect. And this again highlights the regulative role of the springboard and also emphasizes the role of task dynamics in the regulation of complex skills. Finally, this is my last slide, but I have some summaries, some conclusions, of course. You see the variable error in footfall position during the run-up here, and variable error is thought to be an indicator of regulation. So the larger this variable error is, the more regulation occurs. This is according to Lee and colleagues, and a peak value in variable error always defines the beginning of a regulation phase towards the placement of the feet on the springboard, which is shown as touchdown here. So what becomes obvious was that when performing the tuck leap to landing on balance beam, gymnasts began regulation on average one step earlier as compared to when performing the straight leap to hang on the uneven bars. So regulation began here when performing on the uneven bars, but regulation began here when performing the balance beam. So again, a clearly task-dependent effect. So taking the results together, it is quite clear that gymnasts utilize the position of the springboard in order to regulate the runner and to perform an accurate reactive leap in a variety of tasks in which this particular skill is of course important. Can almost be seen as a task-dependent invariant motor control. However, the scaling of kinematic parameters, and hopefully I could make this argument, depends on the dynamics of the tasks. For instance, the dynamics of the hurdle when performing handsprings or Yurchenko vaults also is different, quite different from when performing balance beam, when performing on the uneven bars, but it still results in accurate and precise foot placement on the springboard. Let us now come to a short summary and some conclusions on the ideas that I wanted to talk about. So we started by talking about visual perception in complex skills in gymnastics. We started here identifying visual spotting as one particular strategy, or visual anchoring as one particular strategy in performing these complex skills. We also talked about that gymnasts have their eyes open most of the time, even at high angular velocities of the head. You may recall this picture sequence of this Florentine next week here. And what we can conclude is that Gymnasts attempt to fixate their gaze on specific locations to enable the visual system to provide orientation information needed in the performance of an aerial skill. And this is quite task dependent, so you always have to make a point in daily training, which are these specific locations, how are they related to task performance or to movement kinematics. So what is their functional relationship actually, or their contingent relationship to complex skill performance, and this is what may also help in the prevention of lost skill problems. You can only speculate about that, but could be one approach. We identified the perception-action cycle as a theoretical foundation for the role of gaze behavior as well as the role of environmental information in complex skills. We talked about how action and perception interact in the emergence of motor behavior, that this is dynamic over time, or that this changes over time. And it became obvious that a particular motor behavior emerges as a function of perception-action coupling. This is stable in a specific set of constraints and also changes as a function of sensory information. So again, for gymnastics training, what is this sensory information? And what is the function of this sensory information to a specific motor behavior? If you bring together gaze behavior and environmental information, you could easily think about millions of interactions that are potentially possible. And if you find the best solution for each individual gymnast, then it's quite probable that he will or she will perform to their best. We talked about visual strategies, and they were characterized also to be task dependent, but correlated with motor behavior, as we saw in this example. We can conclude that gaze behavior in complex gymnastic skills is contingent upon kinematic parameters that are important in terms of task execution and task demands, and these contingencies are likely to change or develop during training. So it may be advisable, however, to explicitly practice these contingencies instead of just accepting them to develop as some sort of byproduct in skill acquisition. We sometimes have the feeling that coaches only accept gaze behavior to develop as some sort of byproduct, but they do not emphasize it in training. My position would be to put a strong emphasis on gaze behavior, but also on the interaction of gaze behavior and environmental information in skill performance, but also skill acquisition. Finally, we identified some functional relationships between environmental information and movement regulation, and it can be concluded that movement behavior in gymnastics varies as a function of task-dependent environmental information, and manipulating this information is likely to influence motor skill acquisition. However, we can speculate about a lot of things. There's not much research on giving clearly quiet advices on how to integrate this in training. However, trying to put a little emphasis on it in daily training should be one idea of optimizing individual skill performance. Finally, I may thank some wonderful people that have contributed to this research that I presented in my lecture. In particular, I have to thank, there are many thanks to Kostas Vensas, Damian Hiereit, Pia Finken, Anja Brinker, maybe you know her, she's a former German gymnast, she's now studying at the University of Hildesheim. She did this research with the gymnasts performing the leaps on the balance beam and on the uneven bars. It's her bachelor thesis. If you're interested in this thesis, I can contact Anja to give you more information. But also many thanks to Isabel Artmann and Linda Hennig. And here is the contact information, of course. Feel free to contact me anytime. Thanks for your patience and attention. I guess I'm a bit early concerning time, however. Maybe there are some questions, not sure for the moment, so many thanks for your